panelists and also the QCrete officials for this wonderful webinar. I'm thankful to QCrete to join hands with Indian Concrete Institute Bangalore Center to watch this wonderful webinar. We have eminent speaker, Engineer Lopamudra Sengupta, Head of Technical Services, JSW Cement Limited, for which I also belong. We are talking about role of PSC and GGBS in sustainable constructions. Very recently, I got a call from an exporter. He told me he wanted some 2 lakh tons of slag for export to Germany. And somebody called me other day. They wanted some 1 lakh ton of slag to export to Africa. I was wondering how that is happening. Like everybody is coming to India and wanted this slag, raw material slag. Just for my out of my curiosity, I inquired what's happening, why you want so much of slag from India. They were telling me that like entire Europe by 2050 they have to have a net zero concrete. That means to say they make concrete, the carbon emission should be zero. Friends, you all know that 1 ton of clinker production liberates about 920 kgs of carbon dioxide. If you want to make 1 ton of clinker, we have to use 1.5 tons of limestone. Once again, we have to burn coal of 0.22 metric ton per ton. Electricity 50 to 60 units we are going to use. So to make clinker, we are burning the raw materials along with limestone. Then that is emitting carbon dioxide emissions. Okay, friends, you all know without cement there is no concrete production. Only recently we have evolved a geopolymer concrete, which is making use of industrial byproducts like slag or fly ash or other mineral admixture like metakaolin, microsilica, to a small extent to make concrete without cement. But so far, what all we are building, it is with cement only. So cement liberates about 5% of the carbon dioxide emissions globally. Construction industry emits about 30% of the carbon dioxide emission and 10% of the fine dust. Currently, we are producing about 4.3 billion tons of cement, which is going to be 7 billion tons by 2050. So India is emerging. The population growth is phenomenal. Already we are reaching about 132 crores. Then we are overtaking China very soon. With all that, construction is going to be there. We are going to build longest tunnels, tallest bridges. Everything is happening in India. Recently, Prime Minister Modi inaugurated the world's longest tunnel. We are building one more bridge, Chennai Bridge, which is the more than the height of our Eiffel Tower of France. So the height is more than, I think, 380 feet. 380 meters, sorry, not feet. So very soon we're going to have very tall buildings, maybe 1 kilometer tall buildings. It's going to happen in India because we have a huge population, economy is growing, and India is investing heavily on infrastructure. So coming to this, okay, the role of slag, or which is it's a basic raw material for making PSC cement, GGBS. GGBS is mixed in RMC plants. PSC is mixed in to make composite cements and PSC cement of various grades. So these are the products of the future. Today we have eminent speaker, Engineer Lopamudra Sengupta, coming from JSW Group, which is mainly producing eco-friendly products. I don't want to introduce much about JSW Group. I would like to create the platform to the speaker so that Madam is likely to share how JSW is developing the new products which are eco-friendly, green, reduce the carbon footprint. At the meantime, durability. Durability is enhanced 2 times, 3 times, 4 times more because of usage of this materials like PSC and GGBS. Forward to the organizers, Aishwarya, to introduce the speaker. On behalf of Indian Concrete Institute, I wish the program a grand success. Thank you.
Good afternoon, everyone. I'm Aishwarya from QCrete. Yes, sir. Good afternoon, sir.
Yeah,
I'm
good
Aishwarya
afternoon.
from QCrete Readymix India Private Limited. It is a honor for us to have Mrs. Lopamudra Sengupta to have us today on our QCrete webinar 23. When we asked her to present a webinar, she immediately agreed. So we are very thankful to you, ma'am. She has completed her civil engineering in Jadavpur University, Kolkata, and MBA in marketing, and currently she PhD from IIT Kharagpur. Mrs. Lopamudra Sengupta got 20 years of experience in cement, cementitious products, concrete, and construction technology. She is an active member of BIS committee, Indian Concrete Institute, Indian Road Congress, steering committee member, and she was an expert member for Heidelberg Cement, and she was an executive Lafayette. She as vice president for this cement. I request her to share her thoughts.
Good afternoon. Hi. So thank you very much. Firstly, my heartfelt apologies because yesterday only we had this webinar planned and I was also looking forward to it because we had been discussing with QCrete management and all since 3-4 days. And I was looking forward to my session and interaction with you all. But there was a major Tata power failure. I think Mumbai has not experienced that kind of failure in last 50 years. And what happened, there was no network, there was no electricity, no drinking water. And subsequently, when the power, etc., was restored, the broadband connection and mobile connections were also very weak. So we could not conduct. So it is indeed good that you people have joined at a short notice, and I am very happy to be here. So let us make this interaction more participative. So I hope you can see my screen, and today I will take you through the role of PSC and GGBS in sustainable construction. So I will start with the basic JSW guiding principle, the vision, the mission, and the core values, what we have. And I would like to, draw your attention, being positive, transformation to every life we touch. Mission is supporting India's growth in core economic sector. Core values are confidence, collaboration, commitment, and all the other values which you can see are here. So this is something which we, very much believe upon, and we believe our organization is there to bring best of the product and best of the services to people. So we are having JSW organization as a whole is a $13 billion conglomerate with presence across steel. We are having 18 million ton capacity, which is, going to be further augmented. JSW Energy, we are the third largest player in energy. JSW Cement, we are a young company, but with a lot of ambition and with a lot of plan to grow. 14 million ton is capacity, and we want to, grow up to 30 million ton in the upcoming years. And we have got infrastructure like ports and terminal, and JSW paints factory are there in Vasin and Vijayanagar. So this is the group, our contribution towards India's progress, a lot of education, then this vocational training course, the Olympics, the athletes are trained by our organization. So if you go to our Vijayanagar into our Inspire Institute of Sports, you can see all the, like boxing and judo, everything people are getting, and on tracks people are getting trained. And these Sakshi Malik, etc., have, we have developed them under our this Inspire Institute of Sport. So Metro Rail, developing India, doing a lot of work there, they're laying down new pipelines. So the company started in 2009 with the introduction of JSW PSC. Then 2012, our Nandial plant was established. We got our first Green Tech Award. The product was green. Then we got 2016 the Best Business Enterprise Award. 2016 we had launched our premium product Concrete HD in South. Then we went to PSC cement launching in eastern part of India. We started Shalboni, we expanded Vijayanagar, Dolvi, and then we went into Jajpur, and progressively we have also set up one unit in Fujairah. So now today we have also acquired one unit of Shiva Cement, where we are going to very shortly put up a clinkerization unit there. So this is the journey which we are sharing with you. With respect to the units, you can see the Vijayanagar unit. This is 2.2 to 4 million ton, which has been done. Vijayanagar, this is Dolvi is under expansion. Vijayanagar 3.2 million ton. We want to take it up to 5.2 million ton. Nandial, we have an integrated unit of 5.8 million ton, and we have one unit of in Jajpur, another unit in Salboni. Fujairah, we have put up a clinkerization unit. So we are going to cover the topic of PSC and GGBS. We are going to cover the topic of PSC and GGBS in the role in sustainable construction. So India's first green cement. So we are the first company in India to get our product eco-labeled by CII IGBC. So both our PSC, Portland Slag Cement, and ground granulated blast furnace slag are CII IGBC certified green product, and this is applicable for all our plant. Other than that, we also have got environment product declaration. This is actually very good for us to tell you, because we had competed amongst many top cement manufacturers, and it was found that our carbon dioxide emission percentage was least in the industry, and we have got this EPD declaration for both Portland Slag Cement and GGBS today. So I'm very proud to say only a very few company in India is having both this environment product declaration, which is given here to you, and which is in line with ISO and EN, and both for PSC and GGBS and CII IGBC certified green product. So if you go to CII IGBC website and you type green product, or you search for the green product there, so you can see both PSC and GGBS are listed at green. So you can get various benefits when you use these products under this platinum rating and gold rated building and diamond rated building, etc. So what are the products of CII IGBC, JSW cement, which are compliant to CII IGBC Green Pro certification? Portland Slag Cement conforming to IS 455. This is the mother brand. We are also having ground granulated blast furnace slag conforming to IS 16714-2018. In addition to that, we are showing you these two products here because these are the main two products. Along with this, some OPC is also going. These are the main products, baseline products for the institutional and the non-trade market sales. So if somebody is interested in trade product, we have got other product variants like Concrete HD, that is also a Portland Slag Cement, but it is of people who want immediate quick deshuttering and everything, they can use that product with high strength. We also have composite cement. Composite cement is IS 16415 compliant. Along with that, we have got raw slag which is there. Raw slag is there. Raw slag can be used as a replacement of sand. So 25% to 50% replacement can be done for the coarse and the fine aggregate part. So we will just explain to you what is this blast furnace slag. So blast furnace slag is basically silicates and aluminosilicates of lime, which are developed simultaneously with iron in the blast furnace. The slag which comes out of the blast furnace is rapidly quenched in air, and then it is passed over a then it is ground in a vertical roller mill or roller press to a very, very fine powder, which is called GGBS. Okay, so then I will go to the next slide. So what is the chemical composition of GGBS? I would like to tell you. So GGBS composition, you can see the unique composition which makes the GGBS is having a lot of percentage of calcium oxide. Any other product, if you see, you will not see. So if you actually compare a fly ash is to a GGBS, you can see here the calcium oxide content approximately goes beyond 30 to up to 40% it goes. So the glass content is also 97.5%. It is very, very fine glass content. And with help of this glass content, you can see here the product which will have the product which we will be making will be having a lot of, it will be very reactive, and the particles of slag will be so good. It is not only going to give you strength from the calcium oxide, the lime content is at 30 to 40%, but it will also give you the durability you require, and it is also going to give you added benefit, the workability of mix, etc. So we are showing you some microscopic examination of glassy nature of GGBS particle. So we are just enclosing some test certificate. You can see here our this glass content goes up to 97% also. Many cases here the test certificate which has been done in NCCBM, it is 95.5% glass content. So if we actually, I was talking about comparison of cement clinker and PSC and GGBS and then fly ash. If you see actually cement clinker calcium oxide is having 62% cement clinker. In cement clinker, calcium oxide is 62%. In GGBS, it is approximately 40%. But in fly ash, it is very less. It is approximately 3%. It is very much evident from the mineralogical constitution analysis that the hydraulic properties of slag are equal to that of limestone. So basically, slag, what you see here, which is ground into GGBS, it is as good as a clinker. The lime which is used to charge the blast furnace is coming out in the form of slag. So silicon dioxide is present in all. It is also present in GGBS, and it is also present in fly ash. Now, if we see fly ash, what happens in the case of fly ash? Fly ash is, different pockets. It is collected. Different places will have different fly ashes. People are getting very environment conscious. It is extremely difficult to get good quality fly ash also. So now the slag which is coming, this is coming from a controlled source, and the manufacturing is also controlled. Hence the slag which is coming is a product of controlled production. The parameters which we'll have will be as good as cement, if not, or cementitious product, if not equally better. That's the reason if you see the IS codes are permitting replacement of slag up to 70%. If you see EN, British codes or European codes, the slag goes up to, in EN codes, the slag goes up to 90% also. Places where there is a lot of marine environment, cold weather is also there. But however, even in EN and also in IS, the slag replacement percentage, though it is very, very much on the higher side, but the fly ash can go up to maximum 35% because of the, different sources fly ash coming. We don't know whether it is dry, and it is just mixed like that. Very few manufacturers are processing fly ash. In fact, nobody is processing and adding fly ash. So this is the difference. Wanted to show you the GGBS, the powder which is there, the whitish colored powder which is mixed with OPC to make an inter blend of Portland slag cement, which is OPC plus GGBS. It is pre-blended factory. So we are showing you the slag powder, which is conforming to 1S61714. This is used as a partial replacement to OPC cement in concrete production in RMC batching plant and site bleaching plant. So this is something which we have already shared. I will not repeat this. So what are the hydration mechanism which is happening? So when OPC is mixed with water, there is a calcium silicate hydrate gel which is formed, and calcium hydroxide is also formed, which is a byproduct. So this calcium hydroxide, normally what it does, it goes and occupies the space which is very near to the aggregates, because those spaces are spaces where there are a lot of pores and voids are there. The water which is there inside slowly gets evaporated, and calcium hydroxide goes and, or the water interacts with the cement. the calcium hydroxide goes and takes those places. So this calcium hydroxide, supposing a concrete which is having a lot of calcium hydroxide, you'll see white particles have come and the lime has leached out. What happens? Where limes has leached out, pores and voids will be formed, and through those pores and void, the particles of the environmental agents are going to go inside. They are going to sit on the reinforcement rod or corrode the reinforcement rod, and there will be a lot of complication in the concrete structure. It will be distressed. So in order to finish this calcium hydroxide, what has happened? We are adding slag. So slag, which reacts with calcium hydroxide to form another layer of calcium silicate hydrate gel or tobalmoride gel. So this gel is very good, and this is going to utilize all the calcium hydroxide in the system. It blocks all the capillary pores. It reduces permeability. With reduction of permeability, there is also a high gain of strength, and the durability of the structure obviously increases. So we will like to just show you the, the pores and gel. So when you are using 28 days, when you are using, you can see here the pores and gel, they have become in 3 days, they were very big, with the hydration products of the slag coming in, the pores and gels become, smaller, and the durability of the structure increases. The permeability of the structure reduces. We will talk about sustainable development. Sustainable development is concrete compressive strength. So now people will be telling us about the concrete compressive strength. So if we are comparing a PSC cement or a OPC cement, if you can see the strength here, or OPC GGBS 40%, OPC fly ash, you can see the long-term strength. The short-term strength will be almost similar. That's 28-day strength. But the best part about slag, the long-term strength of the products of slag will give you a higher compressive strength as compared to fly ash based or OPC based concrete. This is the compressive strength. Then we are going into flexural strength. Here also you can see the flexural strength of M40 OPC and M40 PSC. You can see the flexural strength are also improved here, and it is in line with OPC, if not better. The heat of hydration, I'll just briefly cover the principles in general, and we will share the detailed presentation. The heat of hydration of the products of slag are very good. Very good, it is comparatively very less as compared to products which are made with purely OPC. So we have done some tests of heat of hydration at NCCBM. Cement has given a heat of hydration of 853 kilojoule per kg, whereas fly ash is giving a heat of hydration of 663 kilojoule per kg. Slag products are giving a heat of hydration of 228 kilojoule per kg with 50% replacement. So you can see the thermal gradients of the mass concrete are reduced. The temperature of the concrete goes down. There will be very less cracking in the concrete structure. And again, going back to the same thing, the durability of the structure will be improved. The exothermic chemical reaction, when water is added to cement, there is a lot of heat which is getting evolved. So that thing can be controlled with products of slag. Very important parameter. This is a new parameter which has come in and which is very much prevalent. So there is a trans-harbor link which is made on the Arabian Sea, and it is going to be some 30 kilometers long, and it is going inside the sea, and it is connecting different parts of Mumbai. So here, if you see this trans-harbor link, we are showing you the photo here. So the contractors are L&T and Tata Projects, and they had done so many trials. They have done, each must have done more than 100 trials each with OPC, OPC fly ash, OPC slag, OPC GGBS, then OPC GGBS microsilica. Each of them had done, and after all doing, we could see only the products of slag. So there, this chloride migration coefficient test as per NT Build 492, which should be less than 2, could be only achieved with GGBS. In this extremely aggressive environment, no other product could, take care of this. We move on to rapid chloride permeability test. This is a very easy test, and it is very easy to do it in the laboratories. If we see the various replacement of GGBS, 0%, 25%, 40%, 50%, we see normally with 50% replacement of GGBS, the rapid chloride penetration, the charges which are passed are very, very less. This is some approximately 500 to 600. If there is only OPC in the system, you can see it goes beyond 2000. It is sometimes it goes up to 3000 to 4000. So the more slag we add, the readings are very, very less, and it becomes very chloride anion penetrability reduces, and the structure becomes such that external agents like chloride, sulfate, nitrate, etc. cannot come and infuse inside the concrete, and the structure, behaves in an impermeable and strong manner. So RCMT test we have already discussed. I will not repeat. RCPT we have discussed. So this is again a diffusivity slide, a very important slide. You people must have, everybody must have seen this, many people. So OPC diffusivity is 44.7 into 10 to the power minus 9 centimeters square per gram. Basically, there are a lot of pores and voids and channels in the system, and when you are using OPC, there is a linkage which is happening in this. And when there is PPC cement which is used, PPC cement is used, then the diffusivity reduces to 14.7. However, there is a drastic drop in diffusivity if Portland slag cement is used. Portland slag cement, which is the replacement level is 55% here. The diffusivity level is 4.1 minus 9 centimeters square per gram. A very, very important test, water penetration test or water permeability test. It should be less than 10. We are basically going into the main concept. So 50% OPC, GGBS plus OPC is going to give you a mean penetration depth of water which is less than 10, which is very good because these are the conditions which the metro authorities normally give for the construction. Along with that, taking care of the sulfate attack, improved sulfate resistance, and alkali aggregate attack. I'm not going into detail because these are topics in itself. The slag products have the ability to take care of the evil effects of sulfate attack and evil effects of alkali aggregate reaction. So you can refer to any textbook, P.K. Mehta and Monterio, or you can refer to Neville and everything. But you can see the photos we have showed here. I will just tell you, alkali aggregate reaction, especially valid where we have reactive aggregates. So in projects like Nathpa Jhakri Power Corporation, which is again in Himachal, or in Teri Dam, where the aggregates are reactive. So there, the alkali, the sodium and potassium equivalent of alkali, which is there, acts with the silica in the cement, and then they create masses, the ettringites, which are expansive in nature. And what is going to happen? There are going to be cracks which are going to form because the products are expansive in nature, and from there, distress of the concrete will start. Similarly, in sulfate, the sulfate soils which are there, if they go in and enter inside the foundation or enter inside the concrete of a building by seepage or whatsoever mean, or sulfate attack, so there also the products which are going to be formed are going to be harmful. And these things we have to take care. So that's the reason slag cement are preferred, slag-based product rather, GGBS and PSC based products are preferred, which are going to reduce this reaction. The green products, on what basis the green product certification has been given? Resource conservation, because we are utilizing the industrial byproduct of calcium oxide. It is conserving natural resource like limestone, crushed stone, sand. Carbon dioxide reduction is there because we are not making that much clinker. We are utilizing already, steel is getting made, the byproduct we are taking, and we are utilizing it in our manufacturing process. And energy saving, because we are using alternate energy. So fuel, electricity, etc. is also, there is a lot of, so we are saving on the resource, rather saving the mother earth. So that's the reason we are a very product which is very, very green. So eco-friendly product, lower greenhouse gas emission, lower specific energy, specific water consumption, conservation of natural resource are the key points we have. So compared to PPC and OPC manufacturer, PSC and GGBS concrete reduces CO2 emission to the tune of 25% and 50% respectively. So if somebody is using the products, so if they are using PSC, they will be having a savings of 25 to GGBS 25 to 50%, depending on the percentage of slag which is being added. So advantages of slag-based product, we have already told you. I will just brief here. Reduced thermal crack, reduced shrinkage, better workability, improved cohesion, less cracking, increased durability, improved resistance, and improvement of concrete properties are there. So Portland slag cement and GGBS concrete made with GGBS can be used in piles and pile foundation. Any structure you can use this. Especially GGBS is meant for concrete work, but PSC as a cement you can use from pile foundation to plastering. So our PSC cement and our GGBS are extensively used in Kolkata metro work. So you can be rest assured that the products which you are getting is not lesser than world standard, but in fact it is equal to any world-class manufacturing world standard product which you are getting. So you can see here percentage of replacement depends on concrete mix design replacement and can vary 25 to 70% when GGBS is getting used, depends on the performance criteria. Structures where we have utilized our product, where we have sent our product: Mumbai Metro, Kolkata Metro, Chennai Metro, Bangalore Metro, Mumbai Port Trust, Lodha World One, the tallest building of Mumbai, which is having slag products inside it. So you can think about it. LNG Petronet, Dahej, Naval Dockyard, Port Trust, Innor, and in Port Trust, Mumbai also a lot of projects, they have used our JSW products, IOCL. So 70,000 ton the GGBS has been supplied. It is wrongly mentioned here. It is GGBS which has been supplied. Mumbai Metro, 1 lakh ton PSC and 20,000 ton GGBS which has been supplied. Kolkata Metro, this is fully again made with slag cement. Chennai Metro, both PSC and OPC are supplied. Now GGBS has also started to go. Mumbai Port Trust, Mazgaon, this is again like Trans-Harbour Link. It's a fantastic structure, M50 and M45 grade of concrete. You can go here and you can see the structures inside the sea. Absolute pristine structures have been made and fantastic constructions. And only JSW products could, qualify the aggressive criteria. Similar here in Innor Port Trust. So these projects are matter of pride and joy. Worli Bandra sewage pipeline outage. We also want to show you some of the structures where world over the slag products have been used. So Bhakra Dam, Akashi Kaiko, the bridge in Japan, Bandra Worli Sea Link concrete, the foundations have been used. They had brought slag from Visakhapatnam, not from JSW. Atlantic Ocean Road, Norway, M80, the replacement goes from 80% and above. You can see the grades of concrete here. So some test certificates are there. So I don't want to get into detail of the test certificate. Thank you very much. And I think we can take the questions now. Or whatever is there, I request the presenters and the QCrete management to take over. Thank you.
Hello. Good afternoon. Good evening, all the participants, and good evening, Engineer Lokabudra Madam. We are truly honored to have you, and you had a wonderful session today on GGBS utilization. And Lokabudra Sengupta has covered major aspects of usage of GGBS, and contribution of GGBS nowadays is significant. And I can quote from my experience that in working in Oman, for marine structures we used 70% GGBS and 30% OPC. 460 kg was the total cementitious content, and 0.36 was the water cement ratio for M50 concrete, and about 3 lakh cubic meters of this concrete was produced in 2003 to 2007 in Sohar, Oman actually. So we have a lot of examples in India, and Engineer Lokamudra Sengupta has beautifully covered the subject. We are thankful to you, madam, and we are also thankful to all the participants who have come again, because yesterday, in spite of the network problems and Lokamudra madam could not deliver the lecture because of the network. Still, we are happy that people have come back to hear again on this lecture. Thanks to all of you. And any questions are there? We can you can all say some questions. We can open some questions. I will read out some questions which can be answered. Mr. Asking question which is, when we compare PPC based competition compared to OPC, what is the basis that madam, able to hear?
So I could not hear you about it because there was a lot of
Could you able to hear, madam?
No.
Can I repeat, madam? Can I repeat again?
I'm
When
sorry,
we
sir, I'm
compare
not.
the PSC and PPC based concrete compared to O based concrete, what is the basis considered? Same grade. Okay, okay. What we'll do, what will questions to you, madam?
Yeah, please email the questions to me because you are reading and I'm not able to hear anything. There's a lot of sound coming.
Okay, we'll send you, madam.
You please send me all
We'll
the
send you,
questions.
madam. We'll send you the questions. Okay, madam. Okay, madam. Okay. Thank you, madam. Once again, we are signing off. Thanks, Dr. Mandana, for organizing in a short notice, and on behalf of QCrete Readymix Concrete India Limited, we are thankful to all the participants, and we look forward to meet you again. Thank you all.
Thank you, Kaushik. Excellent webinar. We thank Lokamudra Sengupta from JSW and of Indian Concrete Institute for giving a wonderful lecture on usage of PSC and GGBS. These are all future products, globally most accepted products. India is also accepting and embracing this culture of making construction sustainable, durable. Earlier it was only OPC 4353 grade cement. Let us use them. Construction is faster, but now the message has gone to the mind of all the consumers that using pure OPC cement is detrimental to the, not only to their pocket, not only to their structures, it is detrimental to the environment, what the air we breathe, what the environment we live in. So using sustainable material is going to be the next future. In that direction, JSW has come out with wonderful products and all. I congratulate JSW for excellent presentation. Thank you.
Thank you. I'm able to hear Dr. Manjunath. Unfortunately, I could not hear Mr. Kaushik, so I could not take the questions. Please mail me all the questions and I will ensure you get all the answers. Thank you.
Thank you.
We will send you all the questions back.